Hi there. Welcome to this lesson on Further Pure Mathematics 2. We're on Chapter 2, and in this lesson we're looking at a method which is called the method of differences. Now, the method of differences, it's a method that can be used to find the sum of a finite series, and sometimes an infinite series as well, where the general term UR can be expressed in the form UR is equal to some function of R, take away the same function of R plus 1. Or other similar forms that work in a very similar way. But initially, we'll just look at this form. So for instance, if R was equal to 1, you'd have U1 is equal to f of 1, take away f of 2. If R was 2, you'd have U2 is equal to f of 2, take away f of 3. If R was 3, we'd have U3 is f of 3, take away f of 4, and so on, until we get to the second to last term, which would be un minus 1 is equal to f of n minus 1, take away f of n. And then the last term, un will equal f of n, take away f of n plus 1. Now, writing the same thing down, but using a little bit of color to make things slightly clearer, you'll notice that in the first term we've got minus f of 2, and in the second term plus f of 2. Then we've got minus f of 3 and plus f of 3. That keeps on happening all the way down until we get to a minus f of n and a plus f of n. The significance of that is we're about to find the sum of this series. So when we add all of these terms together, all the terms will cancel. The purple ones, the red ones, the blue ones, the green ones, the yellow ones, all of them will cancel, except for the very first term, which has nothing to cancel with, and the very last term, which also has nothing to cancel with. So by adding all these together, we'll get the sum from r equals 1 to n of ur is just equal to f of 1, take away f of n plus 1. Now, that idea is the central idea in the method of differences. It can turn up in different ways, and the way these things can cancel can happen in different ways, but that is the general idea, which is always followed. We'll have a look at an example. So let's say that 1 over r into r plus 1 can be written in the form a over r plus b over r plus 1. We have to find a and b. That's a bit of partial fraction work to get the question started. And then part 2, using your answer to part 1 and the method of differences, find a formula for the sum from r equals 1 to n of 1 over r into r plus 1. Okay, I'll let you have a go yourselves first. So pause the video, have a go, come back to me when you're ready. Okay, let's have a look at this together. So we said the first thing we would do is a little bit of partial fraction work in order to split this into two parts. That means adding these fractions together. When we add them together, we'll get r times r plus 1 on the bottom, and on the top we'll have a into r plus 1 plus b times by r. As well as getting a common denominator for these two fractions, the more significant thing is that we've got the same denominator on the left-hand side as we have on the right-hand side. That means the numerators must be the same as each other. So from here on, we ignore the denominators and we just focus our attention on the numerator. Just multiplying the brackets, collecting together terms, we'll get 1 is equal to a plus b times by r plus a. Looking at the constant on both sides, on the left-hand side, the constant is 1, and on the right-hand side, the constant is a. Therefore, a must equal 1. Then we'll look at the coefficient of r. There are no r's on the left-hand side, so the coefficient of r is 0 on the left. On the right-hand side, it's a plus b. We know that a is 1, so that means 0 is equal to 1 plus b, which means that b must equal minus 1. Substituting those values back into here gives us 1 over r into r plus 1 equals 1 over r, and the minus 1 for b gives us a minus here, minus 1 over r plus 1. That's part 1 done. Part 2 asks us to use that to find a formula for this. Well, this sum must be equal to this sum, using what we just did, splitting that up into the two parts. And then we look at these terms individually. So starting with r equals 1, the very first term will be 1 over 1, take away a half. The second term, when r is 2, is a half, take away a third. When r is 3, we'll have a third, take away a quarter, and so on and so on. The second to last term, when r equals n minus 1, will be 1 over n minus 1, take away 1 over n. And the last term will be 1 over n, take away 1 over n plus 1. Then we add all of these together. All these colored terms cancel with each other. And the only terms that are left at the end are the two red ones, which are 1 over 1 minus 1 over n plus 1. We can just tidy this up a little bit by doing a little bit of fraction work, and that gives us the formula n over n plus 1. Okay, second example, slightly harder. We're still going to split it up into partial fractions, but this time there'll be 3 fractions, and that'll make the method of differences feel a little bit different when we come to it. Once you've done that, then try and use the method of differences yourself. See if you can make sense of how it works in this particular situation. Once you've done that, if you get a formula at the end, it's a formula where you should be able to actually work out what the sum from r equals 1 to infinity is. Have a go at that as well. So pause the video, have a go, come back to me when you're ready. Okay, we'll have a look at this together. So first of all, splitting that up into partial fractions, we'll have a over r plus b over r plus 1 plus c over r plus 2. Getting a common denominator, we'll have this. These could be just joined together as one fraction at this point if we wanted to. Because the denominators are all the same, we can focus on the top. Now, rather than equating coefficients like we did in the first example, there is an easier way for doing this question, which is to consider specific values of r, which will simplify the numerators. Now, if we let r equal 0, for instance, r equals 0 here will make this term vanish with the b in. It'll also make this term vanish here with the c in. So if we let r equal 0, on the left-hand side, we've still got 2. R equals 0 makes no difference. On the right-hand side, the only term we have is this first one, where we'll have 1 times 2 is 2 times by a. So 2 must equal 2a, and a must equal 1. These terms just vanish. We can do something very similar by setting r to equal minus 1, in which case this first term will vanish and the last term will vanish. All we'll have is the middle one, and we'll have minus 1 times by plus 1, which is minus 1. So we'll get 2 equals minus b. It doesn't matter what r is, we're always going to get 2 on the left-hand side. b equals minus 2. If r equals minus 2, the first and second terms vanish, and all we have is the last term. And if r is minus 2, that'll be minus 2 times minus 1, which is plus 2. So 2c will equal 2, which means that c equals 1. Therefore, we can split that fraction up into 1 over r minus 2 over r plus 1 plus 1 over r plus 2. We can then use that with the method of differences. And look carefully at what happens this time. So putting r equals 1 in, we'll get 1 over 1 minus 2 over 1 plus 1 over 3. If r is 2, we'll get a half, take away 2/3 plus a quarter. If r is 3, we'll get a third, take away 2/4 plus a fifth. If r equals 4, we'll get a quarter, take away 2/5 plus a sixth. And at first glance, it doesn't feel that we're getting terms that cancel with each other. But we do. If we look down diagonally, a bit like we did last time, these 3 red ones, we've got plus a third twice and then minus 2/3. We've got plus a quarter twice and then minus 2/4. And that's because of the form we have here, where we've got plus 1 in the first fraction, plus 1 in the second fraction, but minus 2 in the middle fraction. So that'll keep happening all the way down. The second to last term will be that, and this term will have cancelled with 2 others. The last term will be that, and the 1 over n will cancel with this minus 2 over n, plus another 1 over n that we'd have on the previous term. This time there are 6 terms that don't cancel. All of these terms in black don't have another 2 terms that you can cancel them with. So the formula is more complicated. You'll have all of these 6 terms added together. That can be tidied up a little bit. I won't make one fraction for this question because of the next part, but you can tidy it up into a half minus 1 over n plus 1 plus 1 over n plus 2. And that'll do for the moment. Part 3 asks us to use that answer to work out this sum to infinity. And that's the reason for keeping the three terms separate. A half is just going to be a half, but as n tends towards infinity, these other two terms are both going to tend towards 0. As the bottom number gets bigger and bigger and bigger, both the fractions will get closer and closer to 0, and they'll become vanishingly small. So therefore, this sum, as from r equals 1 to infinity, that should say on the top, will equal exactly a half. Okay, a third example. The difference in this example is that there's two numbers different between these. You've got r plus 1 and r plus 3. Use the method of differences to show that you can get a formula for that sum which is equal to this, where you have to work out what the values of a and b are. And then once you've done that, see if you can actually put in some specific values. It's made slightly awkward because the bottom value here is r equals 21 rather than 1. And give your answer to 3 significant figures. Pause the video, have a go yourself, come back when you're ready. Okay, so part 1, we were told that, so you didn't have to do the partial fraction work this time. We're going to try and find this sum. Well, it'll be the same as this sum because we know those two things are the same. And then we put in r equals 1 and see what happens. So if r is 1, we'll have a half take away a quarter. If r is 2, we'll have a third take away a fifth. If r equals 3, we'll have a quarter take away a sixth. If r is 4, we'll have a fifth take away a seventh, and so on and so on. Second to last term will be that, and the last term will be that. Terms do cancel, but you have a sort of a bit of a jump between two lines. So you have minus a quarter here and plus a quarter there, minus a fifth and plus a fifth. And this will carry on all the way down. So again, all those colored terms will cancel. 4 terms will be left with, these two black ones here, which have nothing to cancel with, because they'd be up on the right-hand side somewhere. And these two black ones down here, which also have nothing to cancel with, because they'd be further down on the left. So the sum becomes those 4 terms added together. Now, at this point, it's worth remembering what the question actually asked us to do, which was to write this sum in that form. So unlike the previous question, where we chose not to add the fractions together because it helped finding the sum to infinity, this time we do want to add the fractions together. So adding all of those together, we know what it's going to look like. 2 times 3 is 6 times n plus 2 times n plus 3 will give us a common denominator for adding those fractions. And then on the top, a half plus a third is 5/6. So we'll have 5 times n plus 2 times n plus 3, and then minus 6 times n plus 3, and minus 6 times n plus 2. The easiest way does seem to be just to multiply out the brackets and collect everything together with the top. So we'll do that. That's what you get when you multiply the brackets out. Lots of things cancel and tidy up, and we get down to 5n squared plus 13n, which is very nearly that form. All we need to do now is factorize, taking out the n, and it is in that form. So we've got n into 5n plus 13, so a is 5, b is 13, over 6 into n plus 2 times by n plus 3. And then the final question was asking us to work out a specific sum where r is 21 up to 30. Now, to do that, this is the formula that we just worked out. First of all, we'll work out the sum from r equals 1 to 30. And sum from r equals 1 to 30 just means putting 30 into this formula, which gives us that, which simplifies to 815 over 1056. We need to take away the first 20 terms. So we also need to work out the sum from r equals 1 to 20, which means putting 20 into that formula. That simplifies to 565 over 759. And if we do this first sum, take away the second sum, we'll actually have what they asked us to do. So 815 over 1056, take away 565 over 759, simplifies to that as a fraction. They've asked for it as a decimal to 3 significant figures. So we'll give it as that. 0.0274 is accurate to 3 significant figures. Okay, that gets us to the end of this lesson. If you have the textbook, then turn to page 19 and have a go at exercise 2A. Thank you very much for listening, and cheerio.